Unit 2, Networking. Good morning everyone, my name is Parsa Jahanfar, and I'm a Junior Network Administrator here at SBB. As you know, I've prepared a very special presentation on principles and design of network systems. So, before we begin, I'd like to say a very warm welcome to the CEO and Senior Network Administrator. Thank you for joining us and being with your very special time. This presentation today will be covering the core principles of networks and networking protocols, followed by a discussion of a range of network hardware and software available to the system developer. So, network types. We have three main network types: wired, wireless, and hybrid. So, wired network type is basically a connection that is made by a cable. Advantages we have over this is control. We simply have control over who is using the network and what connection rates, as you can see from the cable. Security. Then again, we know who is connected to the network since it's via cable, and it allows us to be more secure and diligent. And speed. Since we're using cables, we're going to be experiencing the highest transfer speeds than any other network type. However, drawbacks are cable clutters. So for larger organizations connecting to many dozens of devices, we're going to experience a lot of issues with cable clutters. It's going to be very messy. And we are limited to mobility. Since it's by cable only, you're going to be very immobile. So wireless network is not done via cable and is done through radio frequencies, and devices are just connected wirelessly. Advantages over this is mobility. So you can access the network pretty much in most rooms if it's medium sized, depending on the router. And it's far more organized than wired network. So drawbacks are security. Since you don't have access over who connects to the network, it's going to be very hard to control. Therefore, it can raise a lot of security threats. And one other drawback is speed. You're going to be experiencing very limited speed since the network is through wireless connection, and it's not going to be as quick as wired. So, hybrid network. Hybrid network is a mixture of both, of wired and wireless. So, depending on the size of the organization, so if it's a very big organization, it could make sense to implement hybrids. Maybe some areas work best with wired, and some areas in that organization work best with wireless. So they can use and implement hybrid installation. So advantages over this is flexibility. The organization can be extremely flexible with this method, and it's extremely effective. However, drawbacks are cable failures. So it's going to be experiencing problems such as that, and it's going to be very difficult to install, since it's not a very easy installation, and it can be quite complex on whoever needs to install this. Moving on to the network standards, we have three main network standards: OSI, TCP/IP, and 802.x. OSI is basically how the organization sees and allows the network to be perceived. It consists of 7 main layers. Advantages of using this network standard is network support. The network is supported by a wide range of device manufacturers. Troubleshooting. Since each layer in the OSI model is separated to each other, troubleshooting is made easier. So if there is an issue, let's say in the network standard, since it has 7 layers, you can easily identify where it is and then take action. However, drawbacks are adaptation. So many companies are not convinced to use this model due to the popularity of TCP/IP. And another drawback is effectiveness. So unlike TCP/IP, the OSI model failed to meet practical expectations. Moving on to TCP/IP. Pros of using this network standard is compatibility. So it's not reliant on the operating system, and it supports several routing protocols. Flexibility. It is designed to work with different types of networks. It can be adapted to fit the specific needs of a particular network. And the drawbacks are, it's quite difficult to set up. So TCP/IP is a difficult model to set up and maintain. Another drawback is security. Because it was designed to be open, it does not provide built-in security features. Moving on to the last one, 802.x. Advantages are enhanced security. It consistently requires to be authenticated with all devices before they connect anywhere when you plug in your computer or to a network port. Another advantage is flexibility. 802.x provides a wide variety of authentication methods, including usernames, passwords, and biometric data. However, drawbacks are network performance. Since the authentication process used by 802.x can add additional stress to the network, it can affect the network performance. And another drawback is limited device support. Some devices may not support 802.x, which can limit its effectiveness and network security solution. Moving on to network topologies. So, what do we know about network topologies? We know that it refers to a range of devices in a network. It can have very significant effect on the how data is transmitted and how the network performs. Different topologies have different strengths and weaknesses. So, star topology, you can see that devices are connected to a central hub, and all data is thrown to the central hub. Advantages of using this topology is control at the hub, and switch allows for easy management. And it's reliable. If one device fails, it does not affect the entire network. However, drawbacks are it completely relies on the central hub. So if the hub fails, the entire network fails. And limited scalability due to the hub's capacity. Moving on to ring topology, we can see that all devices are connected in a circular setup. Data circulates around the ring in one direction. Advantages of using this topology is even data distribution, and data travels in a single direction, reducing collisions. However, drawbacks are if there's a break in the ring, it can disrupt the entire network. Adding or removing devices can be quite complex. Moving on to the last one, bus topology. So all devices are connected in a single central hub. Central cable, data travels in both directions along the cable. Advantages are it's simple and cost effective for small networks. And it's easy to set up and expand. However, drawbacks are it's susceptible to cable failure. So if the main cable is damaged, it's going to affect the entire network. And the performance can degrade as more devices are added to the central cable. Moving on to communication. Unicast, broadcast, and multicast communication. We know that these are three different methods of communication in computer networks, each with its own purpose and characteristics. So unicast communication is a one-to-one communication method where data is sent from one sender to one receiver. Multicast communication is a one-to-many method of communication where data is sent from one sender to multiple receivers. And broadcast communication is a method which is one-to-all communication method where data is sent from one sender to all devices on the network. We know that communication is a network that involves how data is transmitted and received, and it has significant impact on network performance and reliability. With requirements, basically a network capacity to transport data from source to receiver. The speed of data transport increases with bandwidth, which will result in faster and more reliable connection. Network protocols. There's three main network protocols: IPv4, IPv6, and HTTPS. Starting off with IPv4, it's a system that assigns every device on the internet with a unique numerical address. It's pretty much like a phone number for devices. It helps them send and receive information on the internet. Additionally, it is facing issues with capacity nearly being full and usually completely depleted, which is another topic on IPv6 and purpose wide state. So, uses are network connectivity. IPv4 is the main protocol that enables devices to connect to global internet. Network management. Network administrators use IPv4 for tasks like configuring devices, setting up firewalls, and monitoring network traffic and troubleshooting connectivity issues. IPv6 is pretty much the reason why it's there. It's due to the limited capacity of IPv4. It's an upgraded version of IPv4, providing a larger set for unique addresses for devices to use when talking to each other. IPv6 is needed to support the growing number of online and devices, as the older IPv4 was running out of unique addresses. So in this version, it is a lot more enhanced in security. It has integrated security that is far more secure, and expanding IP addresses. And again, it's tackling the issue that IPv4 is facing. Moving on to HTTPS, which is Hypertext Transfer Protocol Security. It's a protocol that makes sure that your online communication and data are safe, like secure mail or information you send and receive on the internet. It is commonly used to receive for secure websites, online shopping, and protecting your personal information. Uses secure data. It encrypts data between your web browser and the website you're visiting. And verify website authenticity. It confirms that the website you're connecting to is genuine, not fake or malicious site. Moving on to operating principles of networking devices. There's routers. Routers route data between networks based on IP addresses, manage routing tables, and provide security through access control. Switches. They forward data within a local network using MAC address, maintaining efficient data transmission, reducing collisions. Firewalls. They filter and monitor network traffic to prevent unauthorized access and security threats with various techniques. IoT gateways connects and manages the flow of information between the IoT devices, like sensors or cameras, and the internet or central system. Repeaters amplify and retransmit signals to extended networks, overcoming signal degradation and long-distance connections. And bridges. Bridges connect and filter traffic between network segments using MAC addresses, enhancing network segmentation. So, moving on to network server types. We have four server types: domain servers, web servers, file servers, and database servers. Domain servers is such as a DNS server that resolve human readable domain names into IP addresses. They maintain DNS records and distribute them to clients, enabling web browsers and other applications to locate resources on the internet. Web servers, they store and deliver web content such as HTML, pages, images, and multimedia files to a client device over the internet. File servers, they store and manage files that can be accessed and shared by network users, providing centralized file storage and access control. And finally, database servers. They host databases and manage data storage, retrieval, and organization for applications and users. So, access permissions. Access permissions determine who can access a specific network resource and what action they can perform. For example, read, write, and delete. They are a root aspect of network security and access control. So, how workstations hardware depend on relevant networking software. So, CPU, which is known as a processor. The CPU processing power impacts the performance of the networking tasks, such as data encryption and data compression. Operating systems, which is known as OS, is basically where networking software must be compatible with the OS, utilizing its capabilities for network management and communication. Memory, known as RAM, and network buffering. Workstations with RAM can store more data in memory, which is crucial for networking tasks and buffering data that helps manage network. Network interface cards and device drivers. So the type of capacity of NICs determine how devices connect to the network. Networking software relies on networking drivers and device drivers to interact with the NICs. Compatibility between the NIC's drivers and software is crucial for seamless network functioning. Application software. Application software running on workstations depend on networking software to communicate with remote servers and services. Security hardware and network security software. Workstations may have security hardware components or hardware encryption support, and networking software can use these features to enhance networking security, such as utilizing hardware accelerated encryption for secure communications. So, in conclusion, we have now investigated the fundamental components of networking protocols. The growth of business relies on a well-designed network that allows data and communication to flow consistently. It is crucial for the business to analyze and react accordingly to the constant changes of networks, operating the necessary network in order to ensure safe and secure fast networks. This will allow an organization like SBB to remain competitive and to ensure fortified network infrastructure. Thank you for your time and joining me for this presentation. Is there any questions?
Yes, please. For the types of topology,
Yes.
which one do you think is good to implement?
After looking at SBB's requirements and the network they need, we have decided that star topology is the best and suitable topology for SBB, since it will rely on one central hub and it will minimize chances of failure for a device.
Okay. Thank you so much.
Thank you.